maths is not fun? Well, I, Makwana Namraka, is here to show you that maths is just a fun challenge. It is as easy as y equals to mx plus c. And for those of you who didn't know, it is as easy as a straight line. So right now, it is the time for you to grab a paper, a pen, and a calculator and come learn maths with me.
Hey y'all, welcome back to another episode of Learn Maths with me on a hashtag Maths Tuesday. In today's video, we are focusing on Theorem of Pythagoras. So in the previous video, we did a few questions using Theorem of Pythagoras, like while proving whether a triangle is a right angled triangle. But today we are going to be just exploring so many ways in which we can solve question using Theorem of Pythagoras. So what you need to know is that Theorem of Pythagoras applies only on right angled triangles only. So Theorem of Pythagoras applies only on right angled triangles. And what else do you need to know? You need to know that the longest side is called the hypotenuse. So the longest side of an right angled triangle is called the hypotenuse. It is always opposite the right angle. We call it C here. So as you can see, we have a right angled triangle here, and then the line or the side rather, which is opposite the right angle, it's called the hypotenuse, and it is the longest side. So the theorem of Pythagoras states that the legs of the right angled triangle squared equals to the hypotenuse squared. So which are the legs? The legs are these ones that form the right angled triangle. So it means that this side squared plus this side squared gives us the hypotenuse squared. So we'll just be using this formula to find sides and to just prove that the triangle we are dealing with is a right angled triangle. So basically, the theorem of Pythagoras can be used to find missing sides or to prove that a triangle is a right angled triangle. So if a triangle doesn't fit this rule, meaning that a squared, the sum of the two legs of the triangle, are not equals to the hypotenuse, it means that what? It means that it is not a right angled triangle. But if the sum of the legs squared equals to the hypotenuse squared, it means that it is the right angled triangle. I know the theory may be a little bit confusing, but once we start answering the questions, you'll be able to understand. So yeah, let's get on straight into it. So here are our questions. So these are our questions. So as you can see here, we have things that may look like the right angle triangle. So for the first set of 3 questions, we'll just be solving for the unknown sides. As you can see, this is a right angle triangle, meaning that we can use the theorem of Pythagoras to check the missing side. And then for the next set of 3 questions, we are going to prove whether these are right angled triangles. So what you don't know is whether this is a right angle triangle or it's not a right angle triangle. When you look at it, you can just say, I think it's a right angle triangle, even though we don't have a box that indicates it's a right angle triangle. But how do you prove that you think it is or it is not? So we are going to prove that using theorem of Pythagoras. So without wasting any time, let's just get straight into answering the questions. So the theorem of Pythagoras states that a squared, so a can either be this side or this side, and plus b squared equals to c squared. So c is the hypotenuse. C is the longest side of a right angled triangle, which is this one. So this is known as C, right? So here you can put wherever. You can put 4 here and 3 here, and vice versa. You can put 3 here and 4 here. So what we're going to do now is solve, right? We're going to substitute. So what is the value of A? We can put 3 3 centimeter, but this value is squared, plus, now you're going to put your 4. This B and A stands for the legs of the right angle. The legs of the right angle, 4 centimeter squared equals to the sum of the square of the two legs equals to the hypotenuse squared, equals to c squared. So it means that when we know either two values from the triangle, when we know either two values, it means that we can be able to solve for the third side, because we know it is equals to, because we know rather that the formula states this, and when the formula states this, it means that we can solve. You just see when we carry on. So 3 centimeter squared equals to 9 centimeter squared, plus 4 centimeters squared equals to 4 centimeters squared. When a number is squared, it tells us like how many times does this number have to multiply by, has to be multiplied by itself. So if it's 4 squared, if it's 4 to the exponent 2, it means that 4 must be multiplied by itself 2 times. It means that it has to be 4 centimeter times 4 centimeter, and 4 centimeter times 4 centimeter, it's 16 centimeter squared equals to c squared. So the value of this two legs of the right angle triangle squared equals to the hypotenuse squared. So 9 centimeters squared plus 16 centimeters squared equals to 25 centimeter squared equals to c squared. So as you can see here, we have what we have, and we have a we can see that, okay, 25 centimeters squared equals to c squared. But as you can see, we are not looking for c squared. What can we do to change c squared to be c? We're not looking for c squared, we are looking for only c. So how can we make this only c? It means that we have to remove this exponent 2. So as you know, the inverse of addition is subtraction, the inverse of multiplication is division. So the inverse of squared is square root. The square root cancel the squared, and you cannot do only this side, because what happens on the left hand side must also happen on the right hand side. So 25 centimeters squared, the square root of 25 centimeters squared is 5 centimeter, and then the square root of c squared is c. So basically you're just checking which number multiplies by itself to give us multiplies by itself twice to give us a c squared, and that value is c. Which number multiplies by itself twice to give us 25? It's 5. 5 multiplied by 5 is 25. So you have solved for your c. So it means that the length of the hypotenuse equals to 5 centimeter. This is a right angled triangle because the left hand side equals to the right hand side. The sum of the square of the two legs of the triangle equals to the hypotenuse squared. So 4 centimeters squared plus 3 centimeters squared equals to 25, and 5 centimeters squared equals to 25. So 25 equals to 25. I really hope I'm not confusing you. And if you have any questions, please do not forget to leave them in the comment section. So as you can see, now we're moving on to letter B. So on letter B, we can say, okay, we have a right angle triangle. And when we have a right angle triangle, another side is not known. We can use Theorem of Pythagoras to solve that side. In this case, the hypotenuse is known. Only one leg of the triangle is not known. So let's just go ahead and write our formula. A squared plus B squared equals to C squared, right? So you're going to substitute now. As you can see, you have only 12 for the left hand side of the equation, so you're just going to substitute your 12 squared plus, so since you don't have the value of b, which is the base of the triangle, you're just going to write down your b squared equals to 13 squared I really hope that you understand this step. So now you're going to calculate your squared numbers, the values. So 12 squared equals to 144 plus b squared equals to, I think it's 169. 169. So as you can see here, you have an equation. So this side, you do not have like terms. You cannot add 144 with b squared because they're not like terms. But if you take 144 to the other side of the equation, it will be able to add or subtract with 169 because they are like terms. So what you're going to do now is going to say, oh, but this side I only want b so that I can be able to solve for b. So if you want b only, it means that you have to remove each and everything which is on this side of b and take it to the other side. So it means that you have to remove your 144 and take it to the other side of the equation so that you are left with only b and you can solve for b. So it means that you're going to be left with your b this side. B squared equals to 169. So when you take your 144 to the other side, you're going to check, okay, this side is positive, meaning that when it goes to the other side, it has to be negative. So the inverse of positive is negative. So when it goes to the other side, it has to be negative. So you're going to calculate b squared equals to 169 minus 144. It is 25. So you're going to check, no man, I'm not looking for b squared. And if I'm not looking for b squared, I must find a way to remove this squared so that I'm left with only b. So what you're going to do is put on your square root. You don't put it only on b squared, but you put it the other side of the equation, because what happens on the left hand side must also happen on the right hand side. So b squared, the square root of b squared is b. The variable that multiplies by itself twice to give us b squared is b. And then 25, the square root of 25 is 5. So it means that the value of your base is 5. I really hope that you understood how we found this value. Now let's move on to letter C. You can pause the video and do it by yourself because it's very easy, right? So we're going to start by writing our equation. And then you're going to substitute the known values. So in this case, we can just say, okay, we can say this side is our a, and say, okay, our a is not yet known. A squared, you're just going to keep it the way it is. A squared equals to our b is known. 21 squared equals to our hypotenuse is known. 29 squared, right? Now you're going to keep your a squared plus 21 squared. 21 squared is 441 equals to 29 squared is 841. So now you're going to say, I don't want this 441 this side because I want to be left with a only, a squared only, so that I can be able to solve for a. So it means that you have to remove this 441 from this side and take it to the other side of the equation. So you're going to write your a squared equals to 841, and then if it's positive this side, it means that when it goes to the other side of the equation, it has to change and become negative. So your a squared equals to minus 400. So you're going to say, I'm not looking for a squared. The value of a squared, I can see that it is 400, but I am looking for a only. So if I have to look for a only, it means that I have to remove this squared. So I can remove it by putting its inverse operation, which is square root. Then it's going to give you a equals to 20. Yes, your a equals to 20. 20 equals to a. So here we found the missing sides using the theorem of Pythagoras. Remember, the theorem of Pythagoras applies only on right angled triangles. So now let's move on to the next set of three. So this one says prove if these are right angled triangles. So you know that if they are right angled triangles, it means that there's the sum of the squared legs, it has to give you the hypotenuse squared. So we're just going to test using the theorem of Pythagoras formula, so that if the theorem of Pythagoras formula applies, it means that this are right angled triangles. But if it doesn't apply, it means that it is not a right angled triangle. So we're going to start with the first one, which is letter D. Then we're going to write our formula: a squared plus b squared equals to c squared. So here we are not solving for a side or doing anything like that, but we are proving if this is a right angled triangle. So if it is a right angled triangle, we will see it by the theorem of Pythagoras applying. So as you can see already, it means that the theorem of Pythagoras can be used for two things, which is finding the missing sides in a right angled triangle, and which is again proving that these triangles are right angled triangles. So you can prove, and you can also solve for unknown values, unknown sides. So we're going to substitute 3 centimeter squared. I really hope that now you can just see the drill and how it goes, equals to 6 centimeter squared. So you have substituted. So now let's carry on. 3 centimeter squared equals to 9 centimeter squared plus 4 centimeter squared equals to 16 centimeters squared. Then 6 centimeters squared, I think it's 36. Yes, it's 36 centimeters squared. You know, when you deal with similar, like with the same numbers in like most questions, you just keep on and remembering the multiples. Like you just feel like you don't need a calculator, and at that point you just feel like, no man, I'm a pro in this thing. So yeah, so like let's continue. 9 centimeters squared plus 16 squared is 25 centimeter squared equals to 36 centimeter squared. So since the theorem of Pythagoras didn't apply here, 25 centimeters squared, it's not equals to 36 centimeters squared. It means that this is not a right angle triangle, because if it was a right angle triangle, either both of the sides would have been 25 centimeters squared, and either they would have been 36 centimeters squared. So this one is not a right angled triangle. So let's move on to the next letter, which is letter E. A squared. I really hope that you understand. So they are not it is not a right angle triangle, because the left hand side of the equation is not equal to the right hand side of the equation. The theorem of Pythagoras does not apply. So now we're going to substitute 5 squared plus 11 squared equals to 12 squared. So 5 squared equals to 25 plus 11 squared, I think it's 1 to 1. Let's just confirm that. Yay, it's 1 to 1. 12 squared is 144. So we're going to add 25 plus 1 to 1 is 146 equals to 144. So you can see that, no man, this is not a right angled triangle, because 146 is not equals to 144. So now let's move on to the last one. A squared plus b squared equals to c squared. I really hope that you can see that this theorem of Pythagoras is very easy, right? So a squared, you're going to write 8 squared plus 15 squared. It's really not necessary for you to put brackets if they didn't give you the centimeter or units or anything like that. You can just write 8 squared and just leave the brackets out. Then 17 squared, you can just write like this. So 8 squared, I think it's 64. Yay, 64 plus 15 squared, is it 225? Yes, it's 225 equals to 17 squared, 17 squared, 289. So now you're going to calculate 64 plus 225, it's 982. So you can see that 289 equals to 289, which means that this one is a right angled triangle. We have proved that letter F is a right angled triangle. So from this three set, only letter F is a right angled triangle, because on it the theorem of Pythagoras applies. And it is the end of the video now, you guys. I really hope that you found this video helpful and you understood and you liked, subscribed, and you continue to share with your friends. Until the next time, you guys, bye.
If you enjoyed this video, please give it a thumbs up and tell me in the comment sections which topic you'd like me to cover. And remember, I do not promise to know everything, but I do promise to share and help where I can.